Well, hello everyone, and welcome to the Southern California Sector-Specific Drought Outlook. Today is July 23rd, 2026. This is part of our Modernizing Drought Early Warning effort, where our vision is drought resilience for the nation's economic sectors, and we are doing so by delivering sector-specific drought scenarios based on integrated and tailored monitoring and forecasting information that meets the needs of our partners. As is with any sector-specific perspective, we ask questions about what might you be asking about drought, what topics are you considering regarding drought and its cascading effects, and what would you like to learn more about, and what do you think we should learn more about? We are going to be expanding our geography from Southern California to the entire state of California and Nevada, continuing to focus on public health, water, utilities, and agriculture sectors. That expansion will take place in the coming months, and we will release when the timeline for autumn and winter will be provided soon. So for today's briefing, we will follow the familiar pattern of looking at the global perspective, where we'll be looking at global conditions relevant to Southern California sectors, focusing on the regional perspective, where we'll look at Southwest United States conditions relevant to the Southern California sectors, and then finally the sector-specific drought outlook, water utilities, public health, and agriculture. We invite questions as always, and please put those questions in the chat box and we will address those as the presentation progresses. So beginning here with the global perspective, the big story here, as it has been for many months now, is the El Niño Southern Oscillation, and specifically the emerging El Niño event. The reason why we care is that El Niño is related to weather anomalies that are used to predict conditions in California during several subsequent months. An El Niño event began in June 2026 and is rapidly strengthening. And then finally, the ongoing El Niño event is almost certain to become strong or very strong by late 2026 and persist through early 2027. This briefly describes schematically what the El Niño Southern Oscillation is. I'll keep my remarks brief here, but in the El Niño phase of the El Niño Southern Oscillation, warm sea surface temperatures migrate from the Western Pacific to the Central Pacific as winds slacken, those east to westward winds slacken during summer, fall, and winter. And as a result of that, that creates a whole host of effects across the Earth system. One such effect is this. And during wintertime, which is really the canonical season for impacts related to El Niño over North America, we tend to see a change in the atmospheric circulation, which leads to a wetter southwestern United States, whereas we have warmer and drier conditions typically in the Pacific Northwest and in Alaska and in areas of Canada. Now, the El Niño Southern Oscillation is a pretty dynamic process, and we've been monitoring it for some time now in our efforts to better characterize and predict the Earth system. We do so in many different ways. This happens to be the relative Niño 3.4 index, which is the new way in which the National Oceanic and Atmospheric Administration is measuring El Niño and La Niña events. This is simply a region called the Niño 3.4 region, in which we look at sea surface temperature departures from average over that area, and then we use a correction to scale that by the tropical sea surface temperatures across the global oceans. And hence you get a pattern or a time series like what is shown in the right-hand panel here. The El Niño event that we're currently under right now began recently in June of 2026. And as you can see at the end of the time series here, this event is rapidly intensifying. We were in a La Niña event not long ago and have rapidly intensified through ENSO neutral into an El Niño event where we are now. And currently where this El Niño stands is a moderate event. El Niño events of the strong category are not common occurrences. By most accounting, we've had 8 events since 1950, so they happen perhaps a little more than once per decade. The last time we saw such an event was in 2015 and 2016. Now, the ongoing El Niño event is forecast to persist through at least early of 2027, and this is shown here in this slide, which indicates the Climate Prediction Center probabilities of El Niño, La Niña, and ENSO neutral. What you might note here is that there are no blue and gray bars indicating La Niña and ENSO neutral, respectively. They only indicate these red bars, showing that there's almost a certain probability that we will have an El Niño event persisting into early next year. Now, in terms of the strength of this El Niño event, El Niño is categorized by NOAA as weak, moderate, strong, and very strong. And as you can see here, there's a very high chance of a strong or a very strong event by later in this calendar year, greater than a 95% probability. And we are well on our way. This El Nino event is intensifying very quickly, and it appears that this is a very confident forecast, and it appears that it is going to verify. Now, in terms of the current drought in the Southwest and Southern California, we've seen low precipitation and heat, and it's led to an exceptionally poor snow season in the Western United States. Low precipitation and heat has been observed after December 2025 in Southern California. And finally, abnormal dryness has spread across much of California due to recent weather and climate conditions. We've shown this many times in past months, but it's really relevant today because of the water resource situation over the Southwest. This is on April 1st. This is snow water equivalent in the Western United States from the USDA. What it indicates here is exceptionally low snow water equivalent across many of these subbasins and catchments within that region. And no place was safe in the Western United States. This low snow water equivalent spanned all the way from the foothills of the Rockies, all the way westward to the Pacific, and from south to north from Mexico to Canada. Now, in terms of precipitation and temperature, this has been a really extreme season. In terms of temperature, this has been the hottest and almost the hottest, near hottest, the second hottest in many areas of the southwestern United States. And this is compared to 1951 to 2024 and valid for a period of October 1st, 2025 to July of 16th of 2026. On the right is the precipitation percentile rank for that same period, and we can see that in much of the western United States, precipitation percentiles were very meager compared to that 1951 to 2024 period. In areas of Southern California, we did see above median precipitation and percentiles in the 70 to 80 percentile range. Now here in the Southern California area that we're focusing on, this is showing the temperatures, daily temperatures since October 1st of 2025. That's the black line compared to temperature percentile ranks during that same period. And what's immediately noteworthy here is how warm it was, especially during this past winter time in Southern California, especially in the time of March, where there were several weeks in which each and every day in Southern California was breaking the all-time record to that date. In terms of precipitation, while we've seen above average precipitation since October 1st over Southern California, there's a lot of nuance that's missed in that perspective. We saw above average precipitation because of events in October, November, and December, and especially that November event, which was the strongest such November event on record. But after January 1st, we saw just one precipitation event in the middle of February. And aside from that, it's been very warm and very dry. And as a result, that does lead to a whole host of issues on the land surface. So while we did see an above average precipitation season in the water year 25 to 26, it doesn't necessarily mean that we are without issues in that area. Now, moving on here to forecasts relevant to drought. The dry season is underway in Southern California, as it has been for some time, though remnant tropical cyclones and the monsoon may deliver infrequent precipitation, especially in the southeastern part of the state. Now, the big story here is El Nino for Southern California and the southwest United States. Moderate and strong El Nino events are related to above average precipitation in October of one year to September of the following year, suggesting such conditions in 2026 and 2027. And then finally, moderate and strong El Nino events are related to increased water availability in the southwest United States, suggesting such conditions in 2026 to 2027. Now we'll just begin here and look at the ENSO relationships between precipitation and temperature across the United States. And this is relevant for years included in this composite from 1950 to the present. You can see here for June to August that in the western United States, there are increased chances of above average precipitation, especially in areas of the four corner states in which we have the North American monsoon. We do see a smattering of above average precipitation in much of the western United States, but don't let that fool you. This is climatologically a pretty dry time of year in much of the western United States. So while there are green contours here, these green contours don't carry the same sort of weight as if this was a picture for December to February. Now, moving a little bit closer to the all-important winter wet season, this is September, October, November. So really the beginning of the wet season in the Southwest. And you can see that through the green contouring here, above average precipitation is most likely to occur related to moderate and strong El Nino events. So that is part of the perspective and part of the forecast here and outcomes, expected outcomes in the Southwest. And then finally here for December to February, seeing much more of the same, that above average precipitation is related to moderate and strong El Nino events in December to February, indicating the most likely outcome in this part of the country being for such conditions as we move forward. There's a familiar pattern of temperatures that's shown here on the right-hand part of the slide, with above average temperatures to the north, below average temperatures to the south. Above average temperatures are highly likely in the Pacific Northwest related to El Nino. I think what we'll need to see here in the Southwest is how recent conditions over the last several decades will account for how temperature outcomes will look like in the Southwest. I think we'll close right here in terms of Southern California precipitation related to El Nino. So these are for the strongest El Nino events dating back to 1950. So 1958, 1966, 1973, 83, 92, 98, and finally 2015 and 2016. What's immediately clear here is that above average precipitation accumulation is most likely to occur related to strong El Nino events. That is, all but one event, that event being 2015, 2016, saw above average precipitation. And another noteworthy feature here is that a lot of this accumulation that occurred during these historical El Nino years came in these really strong bursts, particularly in January, February, and even into March. So isolated flooding, perhaps even widespread flooding, is definitely a possibility during strong El Nino events. And a picture like this really highlights that. So once again, we welcome your questions. I don't see any right now, so I'll just continue. But if you do have some, just please let us know. Type them in the chat box, and we will address them verbally. Alrighty, so we're going to move on here to water utilities. And this has been a very stressful water season, obviously, in the southwestern and western United States more generally. And we'll highlight these issues here and the reason why they've occurred, but also be a little bit more forward-looking in terms of future scenarios as we see them right now. So we begin here with reservoir and groundwater water storage in California will decline through spring of 2027, as is typical, but remain at least at near average levels, and we have high confidence in that. Lakes Powell and Meade will remain at historically low levels, but above minimum power pool into spring 2027 due to interventions and drought plans that have been implemented, and highly confident in that. And then finally, reservoir storage is expected to increase significantly related to expected conditions associated with the effects of the ongoing El Nino event. We're highly confident in that. The reason here is because it will not take much, it'll take even a near average precipitation year will go a long way in reversing the fortunes of the water situation in the southwestern United States. So we'll begin here with reservoir levels in California, just noting here that conditions are near average almost statewide. In the southern part of the state, I think we've seen a degradation, or at least a decrease in the amount of reservoir storage as a percent of average over the last several months here, but not too much of a cause for concern. One thing to note here is that since the wet season did end early and that temperatures were very, very warm, there's going to be more usage from Southern California reservoirs. So we will have to note that and monitor that a little bit closely. We've summarized this several times in the past, but we do want to highlight it here in the context of the situation along the Colorado River and for Lake Powell, which we'll show in a few moments. A poor snow season was really the biggest story in the southwestern United States. And this here is shown for the San Joaquin catchment in California. That black line indicates the snow water equivalent that had accumulated throughout the season, and that is amid the backdrop of percentile ranks for a history that includes the years of 1991 to 2020. And noting here that really low snow water equivalent for this year was the prevalent feature here, with some really herky-jerky behavior, especially around the 1st of March, as we lost a lot of the snowpack that did accumulate at that time because of the exceptional heat that was prevalent in the western United States. Here's the upper Colorado region, which is the all-important feeder of the Colorado River. The same conventions are used on this slide here, in which we show the black line, which is the current snow season, 2025 to 2026, amid the backdrop of percentile ranks for the history in the years of 1991 to 2020. And here, an exceptionally low snow water equivalent season. And we were just really in a bad way. And this is just illustrated by the fact that about as high as we got during the middle of the season was just nudging the lowest on the record that includes 1991 to 2020. And then that precipitous drop in the month of March because of the heat in the western United States. Now, one thing to look at here, just because of the impending strong El Nino event, as it materializes and strengthens through summer and into fall, is to look at past El Nino years. So we've done so here, and these are indicated by these colored lines amid the backdrop of the 1991 to 2020 history. And you can see here that for these years in the upper Colorado, the snow water equivalent was generally near average conditions for all of these years. Some were a little bit higher, some were a little bit lower, but they in no way resembled the 2025 to 2026 season that we just endured. And it is for that reason that we would expect at least a high likelihood of a reversal of fortunes. This is going to put us in the 90th or 100th percentile this year. From this perspective, that is not the likely outcome, but the very unlikely outcome would be to see a repeat of 2025 to 2026 conditions. Now, Lake Powell elevations have been falling near minimum power pool levels for some time now. And what has happened is there's been a drought plan that has been released, and that plan included Flaming Gorge Reservoir releases of 660,000 acre feet to approximately 1 million acre feet, all in an effort to try to keep Lake Powell above minimum power pool levels. So the projections on the left are for Lake Powell from the U.S. Bureau of Reclamation. And these elevations do include the interventions that occurred in terms of the releases from upstream. And then their projections are shown in these colored lines, blue and green and red. The prediction is for an approach of minimum power pool levels by the time we reach early next year, the time in which we tend to see the lowest elevations in Lake Powell, and then recovery thereafter. And this recovery is based on historical analogs and historical conditions. And based on the forecast intensification of the ongoing El Nino event, this right here would be a more likely outcome in the greens to the blue color here. The least likely outcome, at least according to the conditions that are being forecast to emerge in the Earth system right now, this least likely outcome here would be the red curve. So that finishes up our water utilities scenario here. And we do have several questions. So what I will do is I'll read them off. Is this call interested in getting more epidemiological participation? Yes. I see many of my Southern California colleagues aren't on this call, and I think they would be interested in attending. Yeah, absolutely. I understand this is Southern California specific, but I think this could be massively beneficial to many counties statewide. I'm happy to share or not with whatever target populations you would like. Thank you very much, and hopefully we can follow up on that when this presentation ends. So let's move on here to public health, speaking of which. And with public health here, the feedback that we received from colleagues are the risk of heat-related illness, but also the risk of poor air quality due to wildfire. And we've created two scenarios based on that. First, there is a high risk of heat-related illness in Southern California and throughout the Southwest US in summer of 2026, highly confident in that. And the risk of poor air quality due to wildfire smoke will continue through summer and autumn due to fires across the Western United States and in Southern California as well. So this picture right here shows the air quality index across the Southwestern United States, and also with wildfire symbols superimposed on there to give an indication as to where the wildfires are and try to explain why air quality may be poor. You can see that throughout the Western United States and the Southwest, there are many fires that are burning. But this is not that much different from an average year. And also there's been a lot of good response by CAL FIRE, especially in California, where these fires have been contained and under control. So there really aren't a lot of fires in California that are burning out of control right now, and thus leading to really poor air quality. Now, a lot of the effects right now in terms of poor air quality in Southern California and parts of the Southwest are due to the remote influences of fires elsewhere. And you can see that just in terms of the vertically integrated smoke, the warmer colors indicating more smoke in the air, that in the Southwest, there is some smoke and it's being ejected or moved into the region, but it is not, say, a really significant situation like is being seen in the Pacific Northwest or in the north central United States, just because of the movement of air patterns. In terms of significant wildland fire potential outlooks, this is from the National Interagency Fire Center. On the left, this is for August 2026, and on the right, this is for September 2026. And that throughout areas of the western United States, from the Intermountain West to the Great Basin and the Pacific Northwest, there's an increased wildland fire potential relative to normal conditions. When you look at Southern California and some parts of the Southwest, there is not an increase or above average significant wildland fire potential. That doesn't mean wildfires will not occur there, and doesn't mean that wildfires will not lead to poor air quality or lead to some effects. It just simply means that on the estimation of the National Interagency Fire Center, that conditions will not be above average as they are forecast to be, say, in the Pacific Northwest. Another perspective here that's important to note that is in Southern California, daily average wind speed decreases to its minimum amounts and minimum magnitudes, minimum levels in July, August, and even into September. And we note this here by showing the wind speed as a function of time, October all the way through the following September. The shading here indicates percentile ranks for any given day. You can see here that the percentile ranks are pretty narrow in terms of their distribution, unlike times like March, April, May, and June, which is the windier time of year in Southern California, which would otherwise kick up some dust and lead to concerns related to blowing dust. Over the next several weeks, temperatures are forecast to be above average and a very high likelihood of that. Forecast temperatures in areas of southeastern California are forecast to be, with high confidence, above about 110 degrees Fahrenheit. And while other areas may be a little bit cooler than that, heat is an obvious problem for folks within the region. And this above average forecast extends into the week 3 and week 4 timeframe. So this is valid for a period of the 1st to the 14th of August. And you can see that in Southern California and most of the Southwest, that there's an increased chance of above average temperatures. So that concludes our public health scenarios. And I see no questions on these scenarios or on the region, but once again, we invite your questions, and then we can address them at a later time. So let's move on here to agriculture, which is our final sector. For the first part of the scenario, warm temperatures and increased atmospheric water demand from the land surface and vegetation, it's called evapotranspiration, will lead to greater demand for irrigated water, high confidence. Periods of extreme heat are likely to negatively affect agricultural workers, decreasing their productivity. And that was pretty well documented in the prior slide, where very high likelihood of extreme temperatures in Southern California and many of those areas in which there is irrigated agriculture exceeding about 110 degrees Fahrenheit. So on this slide, we're showing on the left the cropland map. This is from the USDA's GADS product. The mixed cropland and irrigated cropland are shown in orange and yellow, respectively. Rain-fed cropland is indicated by the brown, and obviously in Southern California, where there's no precipitation to be found this time of year, rain-fed cropland really isn't relevant to the situation. On the right, this is a measure called the Normalized Difference Vegetation Index. So it's a measure of how anomalously green or how anomalously brown the land surface is. And you can see in Southern California, in those areas that are with irrigated and mixed cropland, you can see that conditions are generally above average. Irrigation is going rather strong in those areas, and as a result, crops are generally pretty healthy. We do note that in Southern California, in terms of how irrigated agriculture is managed, in terms of water and water rights, that's an exceptionally complicated situation. And we can only help to constrain here the likely outcomes in terms of weather and climate. Do want to highlight here the important effect of temperatures. So we did see those exceptional temperatures once again in spring, March, and April, and in February as well. And as a result of that, that did require a little bit more irrigation, more water for irrigation, for obvious reasons, because that heat will stress out plants and rob them of the moisture that they so desperately need, not only from the soils, but also from their pores. In terms of temperatures going forward, we documented this quite a bit in a few moments ago. Very high likelihood of above average temperatures for day 8 to 14, which is the second week of the forecast. That's valid for July 28th to August 3rd. And then for August 1st to August 14th, a high likelihood of above average temperatures. So the continuation of above average temperatures and the need for even more irrigation in order to keep plants very healthy. We do note this right here again, that there are concerns regarding the amount of water that is available for irrigated agriculture. This is a really complex situation in terms of how water is managed, water is partitioned for irrigated agriculture, but as it relates to water from the Colorado River, there isn't a lot that's being released downstream. And though folks do have senior water rights, especially for irrigated agriculture, so it remains to be seen how much they will have. So with the agriculture scenario, it's shown here. And I think we're about ready to wrap up, but happy to answer any questions if folks have any.